Okay, welcome back. We're going to do section 2.3, the difference of two squares, page 29. Okay, and where it appears in your spec is at the very end of algebra and function strand 3, and you're in part D to convert between factorized and expanded forms, and it's down here. So they call it x squared minus a squared and a squared x squared minus b squared y squared, where a and b are natural numbers and x and y are variables. So we'll be doing all of that during the course of this lesson. Okay, so we'll begin by doing the investigation to understand it at a number level. So a perfect square such as 5 squared would be geometrically represented like this. And the difference between, let's say we're going to use 5 squared minus 2 squared to understand this important theory, okay, called the difference of two squares. It's just a famous factoring. So you have 5 squared minus 2 squared, which means you're getting rid of a 2 squared corner off the top. So you'll see this big L here. That's the shape we're looking for, the area of it. We can count 1, 2, 3, 4, 5, 10, 15, 16, 17, 18, 19, 20, 21. So we could do it by exhaustion, say, sure, that's the answer, 21. Why do we need any more maths? Well, because we want something more sophisticated than counting. We want a shortcut to be able to calculate this. Okay, so, and we don't want to square because squaring is difficult, especially for big numbers. So we want to avoid squaring. And of course the other way would be, say, 5 5s is 25, take away 2 2s is 4, and of course we got 21 that way too, without counting. But there's still a better way of doing it. So when we're taking this L, we'll take this bit here, which is 5, take away 2, which is 3 by 2, and we'll topple it over here. Okay, so now we have this rectangle has the same calculation, the same value in area as this L. Okay, now the height of this is 5 plus 2, which is 7 boxes. And the width is 5 minus 2, which is 3 boxes. Okay, so to calculate the area, the difference of two squares, we can add the bases, take the sum of the bases, and multiply it by the difference of the bases. Okay, so it's the product of the sum and the difference. Okay, and let's check that. We get 7 times 3, which is indeed equal to 21. Okay, so there's our kind of understanding of it, and now we can get down to applying it. And we can apply it in both directions. Okay, so as we always, we'll do the examples from the book. And indeed, we'll just summarize here as they do here. So they're saying that x squared minus y squared, just to introduce variables, is equal to x minus y, x plus y, and x minus y. I'll be honest, I prefer to do it the other way because there's a minus here, and I say to students, so let's write that big. So I like to say we'll cover up the 2's, and we'll write what we see in a bracket, which is x minus y, and then we'll write it again as its conjugate. Okay, a conjugate of x minus y is x plus y, and vice versa. It's just if you go from a sum to a difference. So a quick test for you: what's the conjugate of x plus 7? It's x minus 7. So if you're multiplying conjugates, if you're multiplying a sum by the corresponding difference, so conjugate is a corresponding difference, or difference to a sum, or sum to a difference. Blah, 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 blah. Okay, hope you get it. Alright, so, and it works both ways. So in other words, if I have to multiply this out, I can say it's just x squared minus 7 squared. So the one to focus on is the minus one, because it's the one that links to the fact that you start here with a difference. So it's x squared minus 7 squared. Okay. So the book is really only focusing on going in one direction here and not the other. So I'm going to give you some extra challenges to do, but I'll do what's in the book now to begin with. Okay, so let's do example 1 from page 30. So factorize, 3 factorizations we need to do. 9x squared minus 4 we start with. So the issue with this is it's not written as a square because of the order of operations. If we want it to be written as a square, we'll have to have everything squared, because this square happens before you multiply by 9. So we'll take the square root of 9. So just always remember, if it looks like the difference of 2 squares, then you might want to use your square root button if the number is, if you can't figure it out. But the square root of 9, of course, is 3. Okay, so you have to put 3x here like this, and you have to write the second one. You don't need it. You don't need a bracket, but you do need to write it as a square. Okay, and now we can apply. Now it's not in your tables, so there's no point going looking for it in here. But you do want to treat it as a formula. So just because it's not in the tables doesn't mean you shouldn't write down the identity. So because we're using x's here, we might use a squared minus b squared is equal to a minus b by a plus b. So just because the equation formula isn't in the tables doesn't mean you don't write down the formula. Okay, so this will guide us. So this will say if you're trying to factor the difference of 2 squares, you will start by dropping the squares and using the difference. 3x minus 2. I hope you understand why I can drop that now. And then you will write, this is a difference, you'll write the corresponding sum, 3x plus 2. Okay, let's do the next one. 25a squared minus 81b squared. Okay, so now there's square numbers and square variable terms. Okay, so we'll write this. Square root of 25 is 5a, and we'll put a bracket on all of that. So we'll prioritize the multiplication first, so we have a perfect square. Minus, and if you don't know, you can do square root of 81 is 9. Okay, and then you'll apply the identity, where it's as if you're using that bracket and then that bracket only. Okay, so you're going 5a minus 9b and then 5a plus 9b. Okay, the next bit there is x squared y squared minus 4a squared b squared. Okay, now I will relate this to some indices equations, but again it should happen quite naturally. Where are the indices? What page are they on at all? Well, if you don't know, you have to go back to the index, don't you? And I'll try and learn it off this time. Where's the index even? Okay, here. Indices are on page 21. Okay, so what I'm seeing here is the product of 2 squares, and I can write that product of squares is equal to the square of the product, and that is a power. Here we have it here in reverse, so you have the power of 2 bases is equal to the product of the powers is equal to the power of the products. In other words, That's just xy in a bracket squared minus, now a little bit more going on here, we have the AB, we also have the 2 from square root of 4, so this becomes 2AB. Okay, this is a more challenging question. Okay, and then you say the difference of two squares is the product of the difference of the bases times the sum of the bases. Okay, and I just want to maybe jump into this investigation because it contains some of the stuff that I definitely want you to know. So how can we use the difference of two squares to calculate this without a calculator? Okay, and the idea is you can subtract them and multiply that by their product. You get 200. Okay, now those numbers were very near each other, so we ended up with a small number. These two numbers are very far away from each other. 96 squared minus 4 squared. But luckily their sum, okay, their difference is a mess, right? Their difference is 92. But luckily their sum is 100. So that'll be 9200. Double check that. Okay. And so on. Let's see, you should be able to do the other ones yourself. You should be pausing the video. Subtract them, you get 6. Add them, you get 40. 6 40s is 240. And even 7.9 squared minus 2.1 squared, when you subtract them, you get a bit of a mess. You get 5.8, so we're not happy with that really. But when you add them, you get 10. So the answer is 58. Isn't that brilliant? Okay. So, how about doing some questions for exercises? Okay. Now I will just say it's far more common to be doing questions like 9x squared minus 36 or minus 49. That it will typically be x squareds and perfect squares. Okay, I thought there was one in there where we had to take out, oh yeah, I didn't do example 2. Let's do example 2 now. So before we get on, as I promised you, we'll always do the example. So example 2. 12x squared minus 75y squared. Oh dear, there's no square root of 12 is not what we want because 12 is not a perfect square. Okay, but we go back to our textbook and look at the sections we've just come from. What was section 1 all about? Factorizing with common factors. So this always trumps everything else. So you must look for your common factor, which is 3. Okay, so when you're scooting across here looking at it, you always take out the highest common factor first. It's the golden rule of factoring. So take out the common 3, okay, which leaves 4x squared minus 25. And now you can probably see where this is going. These are perfect squares. Okay, so if you have multiples of perfect squares, make sure to take them out. Take out the 3. So we leave the 3 part, and this is also where you see this word fully factorized, because they don't want you to throw away the 3 as you might do in algebra. If you're solving an equation, you divide by 3, you keep it there. So we're going to factorize this now. But first we need to turn this into 2x all to be squared. Now notice that all to be minus 5y all to be squared. And I'm going to have to introduce what are called nested. Okay, we know what a bird's nest looks like. Well, nested brackets look like 2 times, and we're going to apply the identity now, which will be 2x minus 5y in a bracket and 2x plus 5y in a bracket. As I say, I prefer to do the minus first because there's a minus here already, and I just say cover up the 2's, put that there, and then take your marching orders from this to go here, turn the minus into a plus. So you're almost rewriting this, you're obviously writing its conjugate, okay, or the sum, and difference. Okay. Oop, I turned that from that should have been a 3. Silly me. Okay, scan to see any challenges there. Nothing really, and they haven't. Okay, yeah, there's a few here where, they're all worth doing, but question 10 has a 3 in common. No, it has. No, it doesn't. Okay, which to do? Well, for me, I suppose the easiest ones for me to do are over here on this side, because I can blow it up like that. Okay, so let's do question 3. It will be x minus 2y to be, it'll be x squared minus 2y to be squared, x minus 2y by x plus 2y. Question 6, it will be 3x all to be squared. Now listen to me and say what I'm saying when you're doing it. It'll be 3x all to be squared minus 4y all to be squared. Okay, and we'll apply the identity now. The a squared minus b squared equals a minus b by a plus b. The difference of two squares is the difference of the bases times the sum of the bases. Take it down. The difference of two squares is the product of the difference of the base. The base is the number. If I go 7 squared, 7 is the base, and I'm squaring it. The difference of the bases is the product of the difference of the bases with the sum of the bases. You should know that. You should be able to say that. What's the difference of two squares? The difference of two squares is the product of the difference of the bases with the sum of the bases. Learn to say it, then you know your maths. Okay. We were trying to do this question 6. So finish it here. It's the difference of the bases by the sum of the bases. (64x squared minus 9y squared). 8x, so we write it as the actual difference of two squares. Now go with the difference times the sum. Okay, question 12. xy is already kind of done for us, as well, kind of, but we need to do that, and it's xy minus 2 by xy plus 2. Okay, I'll just write down answers now. This will be 9hk minus 5pq by 9hk plus 5pq. Okay. Number 21, 9hk plus 5pq, blah, 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 blah. Okay. Now, we'll do 20, no we won't, well, we'll do, yeah, you look at that and neither of them are, yeah, so let's look at 27x squared minus 3y squared. So 27 isn't a perfect square, but then again the HCF comes to our rescue. You take out the common 3, which gives us 9x squared minus y squared. Now you keep your 3 outside. We turn this into a square bracket, for instance, because we're going to have lots of round brackets. And keep your 3 times 3x. Don't need that now, actually. Stop that. 3 times 3x minus y times 3x plus y. Okay. 4 will come out. No, you don't have to take the 4 out. That's interesting though, the 4 could have come out. Okay, and you'll get the same answer either way. The 4 could have come out, leaving 4a squared x squared minus 9y squared, 4 times ax minus 3y by 4 times ax minus 3y by ax plus 3y. Okay, enough of them. We'll go on to the next factorizing quadratic expressions in the next section. So as always, see you in the next one.